All right, we're going to talk about graphing polynomials. The leading coefficient, okay, highest degree, the number in front of the variable tells how the polynomial ends. The right side, how it ends. Remember, graph goes left to right, so the end behavior here on the right side. If the leading coefficient is positive, the graph is going to end up. Okay, and if you think about quadratics, when our a was positive, the graph went up. If the leading coefficient is negative, the graph will end down. So if you think about quadratics, when it was negative, it reflected the graph. The highest exponent, so the highest degree, tells me how the polynomial starts on the left side. Okay, if it is even, they're going to start the same. Okay. So if it ends up, it's going to start up. If it ends down, it's going to start down. If it is odd, they're going to start and end opposite. Okay, so let's look at a few generic examples. Odd exponents, so like y equals x, a linear function, and y equals x cubed, a cubic function. So we know a linear function, so odd exponent, coefficients greater than 0, so that's going to be positive. So let's look back up here, leading coefficients positive, it's going to end up. Odd exponent, opposite, so it's going to start down. So this is a positive slope, starts down, ends up. Okay, a cubic starts down, ends up. Now the difference between this one and here, the leading coefficient is less than 0, so that means we're going to have a negative a. So instead of ending up, we're going to end down, and then we're going to start up. So in here, negative slope, and then our cubic function, and the opposite. Since it's less than 0, end down. Okay, when you have an even exponent, like y equals x squared, we know it's quadratic, parabola, y equals x to the 4th. When it's greater than 0, it's going to end up. Since it's an even exponent, they're going to do the same. So in this case, both are going up. And then here, it makes like a W. And then they're both going up. Even exponent, leading coefficient less than 0, so that would make it be ending down. So again, that's like our reflection. So we already know this. Now our leading coefficient is negative. So instead of this parabola opening up, we know it's going to go down. So they're going to end the same, and it's going to be down. Same thing for the 4th root. Okay, the degree determines the maximum number of terms. If the maximum number of terms, it equals the degree minus 1. So if the degree is 5, 5 minus 1 equals 4. The graph does not need to have this many terms. Okay, so it could have, that's the maximum number of times it can turn. Multiplicity is the number of times a factor or a solution or zeros appears. So if it's a multiplicity of 1, your graph's going to cut through. So it's going to make a cut like a straight line. If it's a multiplicity of 2, that 0 is going to bounce. Multiplicity of 3, it's going to wiggle. Okay, again, x-intercepts where it crosses the x-axis, y is 0. Other terms you may see are roots, solutions, or zeros. To find these, you need to set the factors equal to 0 and solve. Okay, so the fundamental theorem of algebra. So the degree of a polynomial will represent how many roots or solutions we have. So we've been talking about that. Solutions it has. Okay, consider this polynomial. So we have 1, 2, 3 zeros. So the minimum degree, that doesn't mean this is our real zero, so the minimum degree is 3. If we're doing factored form, we have g of x equals x minus 3. Remember, factored form come in opposite, x plus 1 and x minus 2. If we're going to expand that, so expanded form means we're going to expand this into standards. We have x minus 3 times x plus 1. That would give me x squared, negative 3 plus 1 is negative 2x. So we take that and then we multiply it by the last factor, this x minus 2. I distribute, I get x cubed minus 2x squared minus 2x squared plus 4x minus 3x plus 6. So I get x cubed, this is a square here, minus 4x squared plus x plus 6. Okay, graphing polynomials, find the zeros and their multiplicities. Multiplicity is the number times the zero is of the factor, so the number of factors. Plot zeros on the x-axis, determine the start and end behavior, use multiplicities, connect the zeros. Okay, in here, this is going to be kind of like a rough sketch. It's not going to be an exact because of the graph's not there. So our zeros and multiplicities, here is 1 0, so x equals 4, 1, and negative 3. Our minimum degree is 3. Maximum number of terms is your degree minus 1, so that's going to be 2. Okay, the start, we look at the degree. The end, we look at the leading coefficient. The A is 1 here, so that's positive. So it's positive, leading coefficient is positive, it's going to go up. The degree is 3, so that is odd, and so that means opposite. So since it's up, it's going to start down. Okay, so starting from x going to negative infinity, then y is going to go to negative infinity. As x goes to end, to positive infinity, y is going to positive. So see how you can see the start and the end to help you with your end behaviors. All right, we're going to plot our zeros here, 4, 1, and negative 3. There's no bounces or wiggles. They're all cuts because they're multiplicity of 1. It's going to start down. It's going to end up. So then we're just going to kind of connect the dots and do that. Okay, notice if we were to find the y-intercept here, it would be at 12. We can't go all the way up. So this is just kind of a rough sketch. We want to know if you understand how it ends and how it starts and then where the zeros are. All right, let's look at the next problem here. Okay, so here the zeros in the multiplicity, so x equals negative 1, 2, and 4. This 2 means that this 2 is going to have a multiplicity of 2. Okay, so that's 1 0, 2, 3, 4 zeros, so minimum degree of 4. 4 minus 1 is 3. And then this is the degree. So the degree is even. So that means it's going to start the same as it ends. The leading coefficient is negative, so that means it's going to be down and down. Okay, everybody understand that? So these both go to negative infinity, because when the graph goes down, negative infinity. All right, plot our points, -1, 2, and 4. They're both going to end down. And then this multiplicity of 2 means it's going to bounce here at 2. So we're going to go up and bounce and connect the dots. You can go higher or lower, but the key is that you know it's bouncing here at 2, and then it goes through those. Okay, let's look at the next one here. The zeros is x equals 2 and -3, multiplicity of 3, multiplicity of 2. This tells me 3 of these, this tells me 2. 3 plus 2, the degree is 5. 5 minus 1, so 4. The degree is odd, so opposite. Leading coefficient, negative. So that means down. Since it's opposite, it's going to start up. Okay, so that's going to be positive infinity, and then it's going to end going to negative infinity. So here at 2, we have a multiplicity of 3, and then here at -3, we have a multiplicity of 2. So let's talk. So it's going to start up. It's going to end down. And then this bounces here, so we're going to bounce, and then we're going to wiggle. So it has to kind of flatten out there. Okay, let's look at reading from the graphs to answer the question. So here our zeros are x equals -1, 1, and 2.5. These are our zeros, and I'm going to let you leave this 2.5 today. We'll talk about that later. So you're going to get f of x, if we're writing in factored form, that comes in opposite, so x plus 1, opposite x minus 1, opposite x minus 2.5. Notice they all cut, so there's no multiplicities here, just of 1. The degree, the minimum degree is 3. As x goes to negative infinity, the graph goes to negative infinity for y. As x goes to positive, it goes to positive infinity. Now, this a, you're going to have to read from the graph. If it's going up, the leading coefficient is positive because it ends up. So you got to check that. Okay, guys? So make sure you're checking. All right, 2 more and we are done. All right, here we have x equals -1, 1, and 3. But at 3, it is bouncing, so that's a multiplicity of 2. Okay, so we have, we're going to do m of x because it tells me there in the graph. M of x equals x plus 1, goes in opposite, x minus 1, and then x minus 3, but this is going to be squared because of that bounce. Multiplicity of 2. 1, 2, 3, 4 degree. They both go up, so that's going to be positive infinity and positive infinity. So let's check this. It ends up, so leading coefficient is positive. And then the degree is even, so they're going to end the same, so they both end up. We're good to go. All right, last one. We have here, here, and here. So x equals -1, 3, and 4. They all cut. So f of x equals x plus 1, x minus 3, and x minus 4. Okay, so that is an odd degree, so opposite, but it ends down, so a negative there. I'm going to let you write it in expanded form, and then you can put that there and check with me. Have a good day.